Hello everyone. In this video we're going to be solving a system of equations. I'd like to say polynomial system, but it's not polynomial because of the radicals. If you want to call this a radical system, fine, go ahead. But we have x plus y plus the square root of xy equals 14, and x squared plus y squared plus xy is equal to 84. And we're going to go ahead and solve for x and y values. We're also going to be looking at something interesting towards the end, which I'll talk about later. Now, how do you solve a system like this? You're probably thinking, okay, we could write everything in terms of x plus y and xy. Can't we? Sure, we should be able to. For example, if you look at the second equation, we do have an x squared plus y squared. So we can go ahead and write it as x plus y quantity squared minus 2xy, you know that identity hopefully, plus xy equals 84. After simplifying, we get x plus y squared minus xy, because these two are like terms, equals 84. Now, along with the first equation, x plus y plus square root of xy equals 14, we should be able to solve this system. Why? Because there's only two variables here. Take a look. X plus y is one of the variables, and xy is the other variable. So in other words, the sum and the product. Make sense? So let's go ahead and name them. Let's call x plus y s and xy p. P for product, s for sum. So our system turns into s squared minus p equals 84, and then s plus the square root of p equals 14. And there's a couple of different options here. One option is you can go ahead and isolate s from the first equation, add p to both sides, square root both sides, and then substitute that. Or you can actually try to isolate p from here. If you switch p and 84, p is going to be s squared minus 84. You know that you can do it, right? And then replace this p with that. So that gives us s plus the square root of p, which is s squared minus 84 equals 14. Nice. Now what are we going to do? We're going to go ahead and solve for s. This is a radical equation indeed, right? Let's go ahead and subtract s from both sides and then square both sides. And when you square both sides, you should be able to get a nice equation. The best thing about it, s squared is going to cancel out. So you're not even going to get a quadratic. This is going to be linear, which is nice. S squared minus 84 is equal to 196 minus 28s plus s squared. Now, like I said earlier, s squared cancels out, leaving us with something nice. Let's go ahead and bring this over here. 28s equals 196 minus 84, which is 112, I think, right? And from here, s equals 4. If you divide 112 by 28, you get 4. Make sense? Great. So we got the value of s. Can we get the value of p? Easily. You can either use the first equation or the second one. Doesn't really matter. Let's go ahead and use the second one. S equals 4. So we have, let me copy that equation here so you can see better. S plus the square root of p equals 14. Replace s with 4. 4 plus the square root of p equals 14. And from here, square root of p equals 10, which means p equals 100. Beautiful, right? Well, maybe, maybe not. Who knows? Now, from here, by way of substitution, if we did it correctly, we should be getting the value of p. But what happens if you use the other equation, right? S squared minus p. Well, if you plug it in here, s squared would be 16. 16 minus p equals 84. Actually, that's not going to give you the same answer, and I wonder why that's happening. That's a good question, right? You probably messed up somewhere. Let's go ahead and check our work. But I think this is going to work. Anyways, let me proceed, and then we can go back and always check our work, because I have a second method, which I think you'll like. But you'll get to decide which one you like better. So we got the values of p and s so far. From here, we could basically set up a quadratic equation by using Vieta's formulas in the opposite direction. Let's say t represents the sum and the product. And by the way, what I mean by that is Here we got x plus y equals 4 and xy equals 100, right? So from here, we basically get a quadratic that looks like this. And guess what? This quadratic does not have real roots, but I know my system has real roots. How do I know that? I'll show you. So we probably made a mistake somewhere here. So let me go ahead and check the other equation. Normally these two equations should work. Let me double check real quick here, okay? We are given the plus sign, right? Okay, they're both plus signs. This is a minus sign, that's a minus sign. And then this gives you s squared minus p equals 84, s plus the square root of p equals 4. Okay, everything looks good to me, but I don't know why the values that I found did not work. We probably messed up somewhere. P equals s squared minus 84, that is correct. 14 minus s, 196 minus 28s plus s squared cancels out. 28s is, oh, now I see my mistake. Okay, there you go. I was supposed to add, but I subtracted. Okay, there you go. I'm like, what is going on here? So this is incorrect. And I'm not going to cut it so you guys can see the natural process here. My thought process, I messed up. So add this 28s, and then you're supposed to add these two things. That's going to give you 280. Exactly 280. I was like 280. Okay, so s equals 10. Great. And now it should work both ways. But let's double check. If s is 10, we plug it in here. We get p equals 16. If you plug it in here, s is 10. This is 4. It's 16. Okay, good. That checks. Great. So we can kind of verify. Now the system gives us the following, because this is x plus y and this is x times y. So we get the following equation from Vieta's formulas, right? You hopefully know that. This is what our equation is going to look like. And guess what? This is factorable. You're looking for two numbers whose product is 16 and whose sum is negative 10. Those numbers are negative 2 and negative 8. So this can be factored into t minus 2 times t minus 8 equals 0, which means t equals 2 or t equals 8. But t represents x or y, or both. So this means if x is 2, then y is 8. If x is 8, then y is 2. Great. So 2 comma 8 or 8 comma 2, which is going to come up later. I'll show you something really cool. But before that, let's go ahead and do the second method, because I think the second method is really cool. But again, I could be biased. You may like the first one better, or maybe you even have another method that you want to talk about. I'm just checking if they're all plus signs, and they are. So we have x plus y plus the square root of xy equals 14, and then x squared plus y squared plus xy is equal to 84. Now, when I found out about this method when I was in high school, I think it was in high school or maybe right after high school when I was in college or something like that. Anyways, I can't remember exactly because it's been a while. But when I discovered this, I was so excited. I'm like, wow, this is amazing. And I just sat down and wrote several problems using this type of identity. Which identity I'm talking about? Okay, let me show you. You take this expression, okay, and write it as follows. X squared plus y squared plus, now I'm going to go ahead and make this a perfect square. Can I? And the answer is yes. Instead of xy, can I just write 2xy minus xy? Of course, right? Now, why is this important though? Take a look. If you separate this piece, this is a perfect square, which is x plus y quantity squared. What about xy? You can write it as the square root of xy quantity squared, even though it's kind of like pushing it. But guess what? It's going to work. From difference of two squares, again, this is what made me exciting and still makes me exciting, that now we can go ahead and factor this x plus y plus square root of xy, and then x plus y minus the square root of xy is equal to 84. You know what's beautiful about this is that we have one of these. This is equal to 14. And guess what? 14 goes into 84. That's what it's supposed to be. Now, if you divide 84 by 14, you get 6. Why is this helpful? Let me show you. Now, this gives you, along with the original equation, another super duper nice equation that gives you what we just found by way of substitution. Take a look at this. Now, we go ahead and add these equations. Ta-da-da-da, we get x plus y 2 times. That's 20, which means x plus y is 10. If you subtract, you get 8 divided by 2. You get the product, which is 4, right? And from here, you get yourself the same system as before. But I think this is much nicer. But again, you'll get to decide. Let me know what you think, okay? In the comment section down below. By the way, I also have another channel called aplusbi, which focuses on complex numbers. Also, make sure to check it out and let me know. Now, let me show you what I wanted to show you all this time. Ta-da-da-da. And it's the graph of these two beautiful functions. Or are they functions? Maybe call them curves, whatever you want to call them. But notice that one of them has a restriction. Why is this only in the first quadrant? Because in this equation, x and y both have to be non-negative. Isn't that awesome? And the other one, what do you think it is? It's an ellipse. But it's not one of those normal ellipses that you have. It's something that has been rotated. And this brings us to the end of this video. Thanks for watching. I hope you enjoyed it. Please let me know. Don't forget to comment, like, and subscribe. I'll see you next time in another video. Until then, be safe, take care, and bye-bye.